Okay guys, we are going to pick up right where we left off in 19.4, but before we do, I just want to draw your attention to this starburst right here. This question that we just finished in the last video, the painting problem, would be very helpful for part 1 on your homework. So make sure that you go back and look at that problem. Okay, let's move on to part 3, the workout problem. So we know that Hans and Franz go to the gym. Hans likes to get right to the exercise cycle, while Franz thinks that stretching first will make his cycling more effective. Hans burns 10 calories per minute on the exercise cycle, starting right away. Franz's stretching takes about 10 minutes and does not burn any calories, but then his cycling burns 15 calories per minute. Hans and Franz want to know who will burn more calories in a 40-minute workout, and when the two of them will have burned the exact same amount of calories. Okay, so those are the two things that we're looking for. So we are going to start by writing a rule for Hans and Franz. So we know that Hans burns 10 calories per minute and that he starts right away. Okay, so if we use C for the total calories and T for the total minutes, we know that Franz's total calories is 10 calories times T, the number of minutes. Okay. When we move on to Franz, it's a little bit trickier because he has that 10-minute period where he has not burned any calories, but he has been working out technically with stretching. So we know that he burns 15 calories per minute and that he stretches for 10 minutes. So we can set it up like Hans with the calories. Total calories is equal to 15 calories per minute, okay? But we have to keep in mind that he did 10 minutes where he was not burning any calories. So we have to take away that amount of calories. So he's been exercising, but he hasn't actually been burning anything. So if we do 10 times 15, that gives us 150 calories that he's basically lost those calories since he wasn't actually burning any, since he was working out, but he was just stretching. So we have to actually subtract 150 calories from his count because during those first 10 minutes, he didn't burn any calories. Okay, so let's go through and I am just going to use my rule to fill in these tables, okay, similar to the last problem. So for Hans, I'm going to take 10 times 0, 10 times 5, 10 times 10, and so on to fill in my table. I get 0, 50, 100, 150, 200, 250, 300, 350, and 400. Okay, and you might be thinking, oh, why is my table jumping by 50? Well, if you look at the change in calories divided by the change in time, so 50 over 5, that actually equals the 10 calories per minute. Okay, so our scale is just a little different on our Y values. All right, so let's go ahead and use Franz's equation to fill this in. So we're going to do 15 times 0, take away 150, 15 times 5, take away 150, 15 times 10, take away 150, and we're going to continue that all the way down. Okay, so at time 0, negative 150, negative 75, 0, and that makes sense, right? Because he starts 10 minutes later on his workout that gives him zero calories, and he's going to start from there. So then we jump to 75, 150, 225, 300, 375, and 450. Okay, and again, our scale is a little off, so you might be thinking, well, why? Why do I see jumps of, I don't see jumps of 15, I see jumps of 75 in my table. And if we look at the same thing that we did before on the table for Hans, we're jumping by 5s on the time column, and we're jumping by 75 on calories. Well, if I take 75 divided by 5, that gives me my 15 calories per minute. Okay, so now we're going to use these tables to figure out when these two have burned the same calories. And you can see that at 30 minutes into the workout, they have both burned 300 calories. Okay, so we're just going to answer the question below. Can you see the point at which Hans and Franz have burned the same number of calories? And we're going to say yes. At 30 minutes, they have both burned 300 calories. And we are done with that one. So we are going to go onto the consolidated activity, and we're going to talk about that real quick here. Okay, so the consolidated activity. So we have two rules here that we're given, and we're going to use tables to investigate these two functions. So I have y equals 3x plus 5, and I'm going to use that equation as my process to fill in the table. So 3 times 3 plus 5, 3 times 4 plus 5, 3 times 5 plus 5, 3 times 6 plus 5, and 3 times 7 plus 5. So my equation is my process. And that gives me values of, let me make this a little bigger, 14, 17, 20, 23, and 26. And again, you can use Desmos or you can use the phone on your calculator. Either one would work fine for this question. So if I'm looking at my process for my second rule, all I'm doing is substituting the x values in. 3 times 3 minus 4, 3 times 4 minus 4, 3 times 5 minus 4, 3 times 6 minus 4, and 3 times 7 minus 4. And that's going to give me values of 5, 8, 11, 14, and 17. Okay. And then I'm just being asked to merge these two tables together into one. So I'm just going to copy what I had in Y1 and Y2 into this table. And you might be thinking that you don't see the intersection. And you're right, in this table we don't necessarily see the intersection. So what we need to look is maybe more at the process, maybe more at the equations, to maybe the rate of change to see what's actually going on here. So for what value of x will these functions have the same value? Okay, so for me, I like to look at this rule right here. And I can see that both have a slope of 3. So they have a slope of 3 and different y-intercepts. So I'm automatically thinking to myself, well, these two lines are parallel, so they're not going to intersect, which means I'm not going to have a solution. Another way to look at that is that you could look at what's going on in the table, and you can see that both of these, you're adding 3 all the way down, which indicates that you have the same slope. So, and you might even be able to see by looking at the pattern that we have 5, 8, 11, 14, 17, and you can kind of see that where the second function stops in the table, the first function picks up. So like you have the same sequence of numbers, and they're just going to keep changing at a constant rate. So there is not going to be an intersection. So there are no x values. And we can say both equations have the same slope. and no solution. Okay. Number 3, what does your observation in question 2 mean about the relationship between the graphs of these two functions? So they never intersect. These lines are parallel and they never intersect. How does your conclusion in question 3 relate to their slopes? Well, that kind of is where we started. So if we talk about same slopes implies parallel lines, which implies no intersection, which implies no solution. So they're all related. Okay, so the whiteboard practice, if you wanted to go ahead and try that on your own, you can, but you are not going to be required to do that, and I am not going to actually go through it. I'm going to post a separate